Good morning. Now I'm going to take seminar on sand casting. What is sand casting? Sand casting is a manufacturing process in which molten metal is poured into a sand mold containing a hollow cavity of the desired shape. After a period of time, the casting cools and solidifies. The sand is taken, then broken away and shaken out. Casting materials for sand casting include metal, concrete, epoxy, polyester, and clay. Sand casting is used for the metals with high melting temperatures such as titanium, steel, nickel, and is the only casting process that can work with those materials. It is a choice of the aerospace and automotive industries for producing low cost and small series parts. First, you will see the components of the sand casting. First, the base sand. The base sand is a sand that is utilized to create the mold in its purest form. A binding agent is necessary to keep it together. The core is also made of the base sand. The basics, the different types of basic sand used are silica sand, olivine sand, chromate sand, zircon sand, and Chacomet sand. The next binding agent. The binding agents are the glue that holds the sand particles together. The following are the most frequent types of the binders. First is clay and water, oil, resin, and sodium silicate. The next one is additive. Additive are used to improve the mold surface finish, it is strength and cushioning. The next is the potting components. This can be the fine powder or the liquid used to facilitate pattern removal from the mold. The next you will see the steps involved in the sand casting. The first step of the sand casting involves the placement of the mold pattern in sand. The size and shape of the casting is directly influenced by the mold. Therefore, the manufacturing companies must create new molds to create metal parts and components in specific sizes and shape. The second step is setting up the gating system. The most casting system involves the use of the gating system, and sand casting is no exception. Consisting of the pouring cup and tunnels or gate to the mold, it is used to funnel the molten mold into the mold cavity. After the placing the mold in sand, the manufacturing company will set up the gating system such as this. Step 3 is the removing the mold pattern. With the gating system setup, the manufacturing companies can then remove the mold pattern from the sand. The mold pattern is no longer relevant at this point. When the mold pattern is placed inside the sand takes its shapes. As a result, the mold pattern can be removed. The step 4 is pouring the molten metal into the cavity. Now it's time to pour the molten metal into the mold cavity. Sand casting supports a variety of different metals such as iron, steel, aluminum, bronze, magnesium, zinc, and tin. Depending on the specific metal or alloy used, manufacturing companies that may use heat up to 3000 degree Fahrenheit. Once the metal or alloy has turned from the solid state to liquid state, it is poured into the mold cavity. After the step 5 is the waiting for the metal to cool. After the molten metal has been poured into the mold cavity, the manufacturing companies must wait for it to cool. Again, the different types of metal can take different lengths of time to cool. As the molten metal cools, it will revert from the liquid state back to the solid state. The final step will be the breakup open mold to remove the metal casting. The final step of the sand casting involves breaking open of the mold to remove the newly created metal casting. While mold patterns are typically reusable, the actual molds are not. Therefore, the manufacturing companies must recreate a new mold each time they want to create a new metal product or component using the sand casting. This is a schematic layout of the sand casting. The first is the pattern reaction, the next the mold reaction, which is the drag box. The next the coke box will be formed. The next will be the mold assembly. The next is the coating of the metal. The finally will be removed of the newly made metal. The advantage of the sand casting are versatility, low cost, simple tooling, adaptability, easy scale up, fast turnaround, a few design limitations, shape complexity, extremely wide range of materials with a few or no process changes, a wide spectrum of the part sizes from gram to tons, lower ecological footprint than most alternatives. The final will be disadvantage of the sand casting. The surface finish cannot be the particularly fine. Dimen Dimensional accuracy and the repeatability can be variable. Contaminated sand cast represents a depositional issue. Patterns can degrade as production skills. The cooling rates are uncontrollable. Complex sand coats for internal spaces can be hard to handle. Non-automated production requires skilled labor. Automated production can require moderate to high cost to establish. Some processes offer low sand reusability and difficult in restoring the sand condition. Thank you.